So to graph the general shape of this equation, we need to find the x-intercepts, the end behavior, and then maybe a point here or there to have an idea of how high and how low those peaks and valleys go. So to find the x-intercepts first, we need to factor this thing. Since it has 5 terms, we have to do synthetic division. Now, that's not too bad, because if we do our p's and q's to figure out our possible solutions, it's going to be 1, -1, 3, and -3. So there's only 4 possible things that we would check, and that's not going to take us too long. So let's try 1. Let's see if 1 is an actual solution. So we're going to run that through our synthetic division. Cram it in there. So that's going to be -1, 3, 3, 1, 1, -3, -3, 0. There we go. So that's good news, because we now know that an actual solution is 1. We know it comes from the factor x minus 1. But more importantly, we now have a smaller expression that we can factor and hopefully do grouping. So this results in an x cubed plus 3x squared plus x minus 3, because we started with an x to the 4th, and when we divide it 1, we're lowering that degree by 1. Now, if I look at these 4, this looks like it could be groupable, because I see the 1, 3, 1, 3. So let's try this. I'm going to factor out a -x squared to get x minus 3. And then, yeah, looks like this thing, if we take just a 1 out, it'd be x minus 3. So that's good news, because that is factorable. So this would be an x minus 3 times the -x squared plus 1. So this -x squared, I'm going to factor that negative out again, because I'd rather not have a -x squared. So I'm going to bring that negative out here, which is going to turn this positive and then negative. Now, I'm doing that because this then is now a difference of squares. That's an x squared minus 1. So I can factor this difference of squares to an x plus 1, x minus 1. Okay, so now what we know are, now what we know is that this is fully factored, and the solutions would be 3, -1, 1, and those are all going to go with our first actual solution that we found. All right, so don't forget about that 1 that we originally got. So we got 1, we got a 3, we've got a -1, and another 1. So I'm going to put a multiplicity of 2 there to show that we actually have that x can equal 1 2 times, or twice. Okay, so now we can graph. Let's see what we have. We have 1 with a multiplicity of 2. We have 3 and -1. We also know the x-intercept, sorry, the y-intercept is 0, 3, because the constant is the y-intercept. Okay, and I'm also going to plug 2 into the equation. It's red here. I'm going to plug 2 into the equation to see how high or how low it would be at that midpoint. Again, it's not necessarily the maximum or the minimum, but it'll be just one other piece of information to help our graph be more accurate. So if we input 3 into the equation, and we can do that with synthetic division, which I think that's how I'm going to do it. If we input 3, -1, 4, -2, -4, 3. Again, you could just plug 3 into x and figure out what you get, but I don't have my calculator, and it's too much numbers to figure out by hand. That's where synthetic division is nice. So if we input 3, sorry, 2. I don't know why I've been saying 3. 2. This is 2. So we'll input 2 into the equation. We're going to get -2, 2, 4, 2, 4, 0, 0, 3. So 2, 3. Again, this is the x and this is the y. So 2, 3 also appears on our graph. Let me get rid of that little dot there. Okay. So now let's figure out our end behavior, and then we can finally connect all these dots. So we have a negative leading coefficient and an even degree. So it's going to be like a negatively moving quadratic because all even degree functions behave the same way. So if I'm going to start on the left of my graph, I'm going to start down here, go up through this, then bounce through the even multiplicity, make sure I go through that point, and then go through there and end down. Now, it's good. I got both of my arrows going down because that's what I expected to get. All right, so that there is a good sketch of this graph. And having the y-intercept and this extra point, they not only help verify that your end behavior is right, but they give us a little more of an idea of exactly how high and how low those pieces of the graph